All right. So, yeah, I'm Janaka Wickremasinghe. So I work for a company called Ascension IT. We, sorry. Yeah, so Ascension IT, and we help telcos to build private clouds with OpenStack and Kubernetes. So help them to sort of migrate from being a traditional telco provider to a more digital service provider. So today I thought of going through looking at different workloads in the enterprise, right? So we have been sort of different iterations when it comes to DevOps and evolution on the workload. It has been going from physical servers to virtual servers and to containers, and then to the serverless era as well. In fact, the workload, utilizing the best of the hardware has been always the drive to make sure that we deliver more efficient workloads, right? So in that sense, the virtualization actually started back way back in 1960s with mainframes. So in fact, the first virtualization wasn't really a hardware-driven hypervisor. Rather, it's an operating system level virtualization, and it kind of grow into the hypervisors, the hardware level hypervisors, and of course in late 90s we see VMware becoming the dominant, sort of coming up with the virtualization technology. And in fact, around, say, 2000s, we see the first open source hypervisor, that is Zen, came out. And around the same time, the KVM, and then we shifted from the workloads from the virtual servers to containers. And so you might ask, why are we going back to VMs, and why are we talking about VMs now? But the real scenario in the market, so actually the virtual machine market in the global, it's actually expected to grow by 177 billion by 2023. And currently its VM market is valued at about 27 billion. And the previous so many years, the growth rate has been about 16%, but it's actually expecting to grow about 20% between 2023 to 2033. So, and if you look at the enterprise world, there's so much of virtualized workloads in the market. In fact, VMware has over like 85 million workloads in there, right? In worldwide deployed. So last 20 years, they have been deploying quite a lot of workloads. So why not look at Kubernetes to adapt and provide a solution for this managing virtual machines through the Kubernetes orchestration layer, right? So like the key factors, like key driving factors, what I see is that the enterprise use of VM is actually driving Kubernetes community to look at bringing on board VMs to the stack as well. So because VM, whatever it is in the enterprise market, it is quite we find it quite regular. The newer application, newer things that might come up with the container platforms, but most of the legacy stuff, some of them are actually very hard to convert, right? So the conversion may be not possible as well. So especially with the, the telco side and all that, the customer sometimes gives you like a appliance. So now the appliance get converted into virtual machines, right? So those virtual machines, you need to have a way to, orchestrate it through the, one single platform. So another good opportunity for Kubernetes is the existing hypervisor cost. So some of the proprietary, hypervisors are quite expensive. So in the at the moment, there's a big adoption of Kubernetes in the enterprise market. So why don't this becomes a part of driving factors to adapt virtual machines into the Kubernetes cluster as well. So, and of course the consolidation part, right? So you currently even when we deploy normally for the VMs, either VMware or OpenStack or some sort of a solution, and then you have the container platform separately, which is becoming a major headache in terms of managing and having a single plane of view. So consolidation and having a single management plane is also another factor why would Kubernetes really look at getting VMs into the stack as well, right? So, and of course, the beauty is the Kubernetes flexible architecture. So the way it is architectured, you can actually bring on board VM and look at the VMs in a more Kubernetes native way. So to make it more infrastructure as a code, so the orchestration and all that, you can make it much more simplified, right? So so the solution is KubeVirt, so just a little background of KubeVirt. So this was started in Red Hat towards the end of 2016 with the exact objective of, why can't we bring VMs to, Kubernetes orchestration, right? So with that started, why would you bring it anyway, right? So you have the leveraging on your existing container network, the storage interfaces, other Kubernetes things, and also the, the KubeVirt is actually you can immediately drop into Kubernetes cluster as well. So going back to the history, so KubeVirt joined Cloud Native Foundation in September 2019 as a sandbox project, and it got graduated to incubating project in 22. And of course, recently in last July, we had the version 1.0. Still it is as an incubating project, but it is now released the 1.0. You may, especially if you are coming from an enterprise background or enterprise side, you might wonder, this is relatively new, right? So, so even though the project is new, the underlying architecture that we are using on hypervisor, like the KVM hypervisor, libvirt, which are more than decades old, right? So those have been tested and thoroughly matured in the industry. So Kubernetes, the KubeVirt really brings that, bring it to the Kubernetes cluster, but the underlying, the hypervisors and the underlying technology is much matured and really tested in the market as well, right? So, okay, so I thought we'll do a bit of a demo. Right. So I thought it might be good to sort of set up a labs to test out this thing. So if you go to the Kubernetes sites, they give you the directions how to set up the labs. And you could use any of the tools to sort of create your Kubernetes cluster. And you have multiple options in that. There are few things broken, like if you use Minikube, it has a KubeVirt add-on, but it is broken. So you have to deploy the KubeVirt manually through an operator. I think we have an operator session as well, so we'll probably go deep into what the Kubernetes operators and stuff. And second, and if it is, so basically you are running a virtual machine, so it needs a hypervisor to run. So you have the option of emulating that as well. So if you are doing that, you need to make sure, you have to mention that, it is emulated. And of course, then once you do that, you'll have to create the custom resource definition. And then you can basically start the KubeVirt in your Kubernetes cluster. So let's go and do that before we come in here. Okay, so I have I have a cluster already set up here, a Kubernetes cluster. So kubectl get nodes. Oh, what's going on? Wrong place. Okay, so this one. Get nodes. Yeah, so I have a one controller running and 2 worker nodes running. So so like I explained earlier, this is just a drop-in solution, right? So you can just drop KubeVirt into the Kubernetes cluster. So okay, so in this, the first thing is to basically deploy the Kubernetes, the KubeVirt operator. So I already have downloaded that. So you can just do a kubectl create -f. What do I have? I have the operator here. Right, so create that, and then you also have to create the custom resource that goes as custom resource. So this will start basically dropping the KubeVirt infrastructure into the Kubernetes cluster, right? So then, so you can see what are the things being deployed. In KubeVirt. Just put all. Right, so so there are certain pods are being deployed to the cluster. So and you can also check on the custom resource that it's called KubeVirt. Namespace is KubeVirt. Did I not create? I'm making yeah. Usually try to do a demo and okay. Yeah, I got it. Okay, finally. Right, so basically, when you look at the custom resource, it'll start with the deployment and then it'll get deployed, right? So if you look at the architecture a little bit as well, right? So if you go here, go to the architecture, right, okay. So basically, there are two components, right? So you have a cluster component and you have the node level components, right? So in the cluster controller, you have the Virt controller, which is doing the cluster-wide managing of the virtualization functionality, and which is responsible for managing all the virtual machine instances. And the whole life cycle and all that is managed through the Virt controller. So you can see the Virt controller get dropped here. Just to get a port list. Okay, ports. Right. So. Yeah, Virt controller, and that is on the controller plane. Oh, wide. Right. So it gets onto the, and then you have the, okay, so you have the controller part, and then you have the, you have a handler, which is like a, which is also like a, it runs per a node, right? So basically, that's basically a daemon that runs per node wise, and which basically communicates with the controller. That also a bit sort of it basically waits for the user's interaction, and then you have the Virt launcher. So the Virt launcher basically gets instructions from the Virt handler, and actually so Virt launcher is another container inside the pod. So that does all the actual deployment of the VM, right? So at the moment. So we have just deployed KubeVirt, and now what we can do is we can create a virtual machine, right? So let me clear this one. Okay. Right. So we have. Okay. So we have a VM here. Right. So this is okay. So you basically, if you right. So you can mention the the name of the VM and size and all that, and then here this part, right? So this is the domain part. So this is specific for the virtual machine. So you can mention what sort of a the disk are you going to use, whether you could even like have a, this fiber LAN or something presented here as well, right? So the usual, the way of having your VMs and all that. And you can mention how much memory and all that you need to create for the VM. And okay, so here we have mentioned it's like the running state is false, and then you can mention. So this is a container disk, basically using pulling the the information through this image, and so you could basically now start this one, right? So once you start this, so you could create the manifest, VM1. Right, so So what it does is actually it does two things, right? So one is it creates a virtual machine template, right? So the template goes under kubectl get VMs or VMs, right? So this is the VM is the template, right? So this will basically tells you how to deploy the final pod, right? And then the actual deployment goes on the virtual machine instance, right? So to do that, you can either remember, like here we had we had mentioned, running false. So by default, it will not start up and running and all of a sudden deploy it. So here, to run that, you can either use a manifest, and then on the spec you can mention the state equals to run, and then you execute that. Or you could use another set of tools provided by the KubeVirt project itself called VirtCTL, right? VirtCattle, right? So here you can basically manage your VMs, right? So here what you could do is, like, now you have the template deployed. So this is like the AMI template in AWS, or like the template in OpenStack, right? And then to start a VM, actual VM from that template, so currently we don't have any actual virtual machines running. So to start it, you can just use the VirtCattle and then start, what's the VM name? Test VM, right? Test VM. Right, so it will be scheduled to start. Now, if you look at the architecture, so this is where, so now it is basically from the controller side, it has asked to start a pod. So if you look at the, actually, like, so it's using all the Kubernetes, it's not messing up the Kubernetes structure, it's just sticking to that, the way of handling it. So, kubectl get pods. Yeah, so you can see that launcher, right? So this is the one that has been actually the pod that has two containers. One of the containers is actually doing the Virt launching part. So in the Virt launching part, so then you can also see kubectl. Now that's the CR, right? So you have the get VMIS. So now you have the virtual machine running with the IP as well, right? And then you could like confirm it to actually running a VM or not also. So you can just do a PSA UX, just do like grep to see whether actually you're running a QEMU. Right? So here you can see all what we have defined in our manifest. It's actually taken that and actually running a QEMU. I mean, it's a virtual machine that is being running, right? So now this virtual machine, we can actually connect to that as well. Just like how you connect to a virtual machine through the console and all that, you can connect it. So VirtCattle console. What was that? Test VM, right? Test VM. So we can actually connect it through the serial port as well, right? So and then just show you something. So give the password. So nothing here. Let me create a file. Come on. Okay, okay, now we have the file, right? Now if we do a restart, exit and kubectl get VMIS. So we have the node running. Now we do a restart of the VM, right? So if you do a restart of the VM, word cattle, let's stop the VM, do a restart. Yeah, restart there. Restart, test VM. Right, so it is scheduled to restart. Now you can see pods, what's happening in the pods. Right, so it's initialized. So this is now behaving just like a, femoral, container, right? So nothing is saved in this manner, right? So now if we KCDL get PMIs, yeah, so it started again, and let me go to the console. Right. So that my file is gone. So it may be the case you want something like this, or it may not be the case that you want like this, right? So normally, when you have the VM, you want to make it persistent, right? So what you can do is you can actually use the existing infrastructure of persistent volume to achieve the same thing. So for that also, there's a small modification where we basically drop another another custom resource called container data import, right? So we need to start that container data import custom resource. So, yeah, there we go. Let's do that. Create cube. Create -f. Let's deploy the container data import operator and then the CR as well. Okay, now we can check the same thing similar way. Cube CTL get container data names is container. Right, so it has been deployed as well. So the advantage of container data interface is actually creates like another abstracted layer for you to import your virtual machine images, right? So this is superb, right? Now you can basically import a virtual machine image into your, the physical, persistent volume, and you can use that persistent volume claim to attach that into your VM. So that way, when you do a restart, you won't get it, nothing will get disappeared as well. Right, okay, so let's do that. So we'll create let's look at this. So that is called a data volume. So that is like an abstracted, the CR or staying on top of the, physical persistent volume infrastructure. So, so here you can basically give the directions where to download, where is the image is stored and all that, and then that can be used to create your physical, persistent volume. Okay, so we do cube CTL create f dv, right? So it's going to create me a dv called COS, okay, cube CTL get dv, come on. Right, so its import is scheduled now. Hopefully, if you look at the pods, okay, so it's actually using all the, it's already imported. Otherwise, it'll basically spin up a pod that actually does the work for you, right? So it's using all the existing methods, right? So now if you look at the PVs, so now you have a claim that can be used in your VM, right? So now you can, okay, let's say this guy. There we go. Okay, so here I'm going to launch another VM called VM1, and that is going to use, that's going to have one core, that is going to use the disk here, the volume. So the claim name is the one, the PV claims that I have created. I can attach that into this, and that one already have been uploaded with the existing, the VM's image, right? So we can create this. Right, so let's look at KubeVirt. VM. Yes, I have another VM running. Okay, so let's connect to that one. Console, that one is called VM1. VM1. Okay. Okay, so okay, now I have that file in there. Let me exit out of this. Okay, now let me do the restart. This one is VM1, right? So now it's scheduled to restart. Let's look at the VMs. Right, so it's scheduled to restart. Okay, it's restarted. So now we connect console. Now, hopefully, we still have the file. So this is the ideal scenario where we want to have with the VMs, right? So one last demo I want to do before do it. So the major, the advantage is sort of, Kubernetes, you can also like have pods running in multiple nodes. So in virtual machine world, it's the ability to shift between nodes, right? So you should be able to migrate your workload across to another node without having a downtime. So that is like the main thing. So if you can do that, like I think that's like we are pretty ready to go with this into the production even. In fact, a lot of people are also using in production as well. So so in fact, the migration also available as well. So to do that, actually, just need to do a migration. Like so, yeah. Okay. Before the migration, let me log into that and do a ping. IP route show ping to this one. Okay, so the VM is running continuously. right? What you want to do is we want to shift this from, let's see where it is at the moment. KCD get PMI provide. So it's on worker, so let me look at my nodes. Get nodes. So I have worker and worker 2, right? So hopefully we migrate it to worker 2 without our process going down, right? So CTL, it's just migrate, okay. Migrate VM1. Okay, so because I have not created the proper yeah, I have not properly created the storage, so I will migrate the other volume. So let me connect to the other one. Let me go to this and break this. Let me migrate the test volume. Okay, go get VMIS. Okay, let's migrate the test volume, right? So let's log in to the test volume. Sorry, test VM. Okay, let's log in there. Let's do a ping. Let's see IP. Let's ping to the gateway. Let's do a continuous ping to the gateway, right? Okay. Now let's maybe even log in. Oh, sorry. Okay. Get VMIS. Okay. So we want to migrate test, right? So we do word cattle, migrate test VM. Yeah. So when it is migrated, so migrate, what it does is actually it's basically keeps copying the disk and then finally copy the memory across, right? So do a bit of freezing and then copy it across. So this is exactly what would have been done with libvirt as well. So they're using the same thing. So get pods, right? So it's already completed. Okay, fine. Right? So what's actually happening is it brings up the other port, that is another VM, but you don't direct into that, and then copy all the data and stuff, and then you started copying the memory, like last bit it freezes and copies the last bit, and then complete the existing one, and then bring up the second one. So it's all done. So let me see, get VMIS. Okay, so it went to worker 2, right? And if you go here, of course, it got broken because you have shifted from the currently connected to worker 1, so the TCP connection got closed. And now the beauty is it should still, when I connect again to the new one, it should still keep running. There you go. So the VM has not actually dropped, so it's continued to run, right? So I wanted to show you some Windows stuff and all that because it actually works as well. But last minute. Okay, right. So just to conclude it, so basically, just last bit I wanted to just touch on it, and like now that we have this thing and it is the KVM and libvirt is all tested and mature product. How do we bring sort of workloads from VMware or OpenStack to our Kubernetes cluster, right? So there are like two ways you could actually do the migration. One is like lift and shift. The other one is actually re-platforming. So the lift and shift is more likely that the legacy application, legacy VM that can be shifted to the Kubernetes cluster as well, right? So it works very well, great with Windows and Linux, and can be automated. The second one is you actually have a modernization plan to go and create, containerized solutions. So in the steps, you basically make sure that your disk is, should be, if it is a proprietary virtual machine disk, and if it is not supported by KVM, make sure, like you have a Cow2 disk or a raw disk or VMDK disk or something like that. And then once you shift it, you may want to sort of insert some of the para-virtualized drivers like the ViRT drivers and all that, and build your kernel. So, and of course, if you are using SE Linux, it's going to freak out once the hardware gets changed, so you might want to do that change, and then network configuration and insert an automation engine and all that. So that will seamlessly set with your Kubernetes cluster as well. So I think with this, I want to conclude. And I hope you all got some insight to, now there's another area that, it's like, now we can handle both cats and dogs both through Kubernetes. So I think it makes the life easier for enterprises. So this is a very good way across. So thank you. And then, like these resources where you could get involved with, KubeVirt project. And okay, thank you.